Hi, I'm Scott Jacobson, Product Marketing Director here at Cadence Design Systems. I'm in charge of Ethernet verification IP products. And today, we're going to talk about hopefully an entertaining and informative topic called the evolution of Ethernet. Now, if you see, this is going to be part 2, all about sharing. The first part in this series, this is a 3-part series, the first part in the series talked about how people communicated and shared services before the concept of Ethernet. Now, in a real world environment, that would be like when you're working with your friends and nobody shared anything except for directly one-to-one. Well, now, when Ethernet came around, the whole world became a shareable world. So when Bob Metcalfe sat down at Xerox PARC in 1973, and he drew his famous diagram on the back of a napkin, and the pictures of that are on the internet. You can see how he did that. He took the concept that he had been introduced to in the Aloha Network investigations in Hawaii to connect. They were trying to connect the different data centers together in Hawaii to be able to communicate to each other. He put those together on the back of a napkin with an architecture, and he pulled in the term ether as part of the feed behind this new network. Ether was actually part of the EMF force. They called it electromotive force. It's called the voltage now in the electrical world. So ether became Ethernet, and the architecture of this was designed in 1973 originally by Bob Metcalfe. Bob had two very simple goals for what he wanted to accomplish with this new architecture. One was data exchange between computers, similar to what he had seen with the Aloha Network in Hawaii. And the other thing that he had focused on was how to print. Another simple goal: how to print files to laser printers. These are very simple top-level goals for what he wanted to accomplish with this new architecture. Now, he birthed the idea on this napkin in 1973. It took 10 years for that to be ratified as an 802.3 standard by IEEE, so that way it became an industry standard network definition, and that was the birth of Ethernet. So if you look at that, well, what's changed there? So what's changed there is, instead of single point-to-point connections, which is the way things used to be, now you could have shared information across computers. You could share printers and resources across computers, so that everybody became part of a shared networking environment rather than just single-point connections. And, you know, if you look back and do a little bit of a historical kind of a look back, you look at some of the first movers in Ethernet. You think about, remember companies like 3Com, like Exelan, Ungerman Bass, Novell, Bay Networks, Synoptics. These were all companies that were in this first stage of Ethernet evolution, back when it was first defined and started to adapt itself for higher performance and better bandwidth management. So, you know, one of the first competitions that Ethernet faced really was in the stack area. In the stack area, Ethernet being, you know, since Bob looked at Ethernet being part of Xerox PARC, the first protocol stack definition for Ethernet was really the XNS standard, which was the Xerox Networking Standard. That later was challenged by the ISO OSI model with the 7 layers and TCP/IP, and it eventually adapted. Ethernet eventually adapted from XNS to ISO OSI, and today everybody just knows it as the ISO OSI model. But it was really a successful competition that had Ethernet evolve into its first challenge of what to do with the stack. The second, another example of some of the adaptation that Ethernet has gone through in the years is in terms of medium. You know, the original definition of Ethernet was really around coaxial buses, coaxial connections on a bus topology. And that was the original intent of Ethernet. Well, they wanted to go into the office space. Well, you go into the office space, the existing installation in there is a phone system. The phone system's a star configuration, and it's twisted pair wires. So Ethernet adapted. It added the support for RJ45 connectors so that you could use twisted pair wiring support in a star topology and still have Ethernet connectivity. And Ethernet has yet evolved after that to another medium, and that is the optical medium for higher performance and higher bandwidth solutions. So Ethernet, the bottom line of this story that I'm taking you through is Ethernet has really been adaptive. It's been challenged. It's adapted, it's moved on, and it's continuing to evolve, and that's what makes Ethernet so predominant in today's world, from automotive to data centers, is that it's got an innate ability to adapt and evolve and continue to address the basic concerns of people, which are data exchange between computers and printing. So, the other part of Ethernet that did come under challenge was the basic transmission format, the CSMA-CD, which is Carrier Sense Multiple Access Collision Detection. I think about this as a family dinner. In a family dinner, you got people sitting on both sides of the table. Everybody talks at once. You can't hear anything. It's all collisions, right? So what do people do? They stop, they back up, and they wait a random amount of time, and then they try and talk again, see if they can get the message across to their brother across the table. That's kind of the way the CSMA-CD standard it kind of operates, right? Is that it looks at all these collisions, backs up randomly, and tries again. Well, that's worked, but it had some bandwidth and performance issues. And along came a challenger called Token Ring. Token Ring said, well, we can solve some of the performance and some of the other issues challenged by Ethernet by creating a token. Think of it like a talking stick at the dinner table, right? So a token was like, if you wanted to talk at a dinner table, you had to have the talking stick in your hand. No one else could talk unless they had it. Same with a token ring. Token ring message would go around, circulate around the network, and the receiver would get it. Somebody else would grab the ring, and they could talk. And so this is very efficient for single conversations, but it also had its own challenges. Token Ring adapted into the Apollo, or was adopted largely in Apollo mini computer networks, which were later bought by Apollo and survived for a while, but Ethernet continued to evolve and surpassed Token Ring as a standard. And Ethernet also evolved naturally into higher performance solutions. Things like hubs came along, where you have shared bandwidth to multiple ports, and then also switches and routers started to come along, where if you wanted to broadcast a message across different subnets, well, then you needed something like a switch or a router. And you could think of that like your mom at the dinner table, where mom knows that Paul on this side of the table wants to talk to Frank over there. Well, mom kind of directs things, says, okay, Paul, now you can talk to Frank over there. Frank, are you listening? Yeah. So mom is kind of like this switch in Ethernet, which improved performance and improved some of the bottlenecks that Ethernet was facing, and it allowed it to increase increase utility of the available bandwidth. And then it's also Ethernet has also evolved recently into time-sensitive networks for priority control messaging, and we'll talk more about that in the third part of this series. What is Ethernet like today? Thank you very much for your attention. Again, if you want more information on verification IP products, please visit the cadence.com website. Go to the verification IP page.